at a rate of 14 meters per minute. Melanie and Sherry sit on the south bank of the river, with Melanie a distance of d meters downstream from Sherry. Relative to the water, Melanie swims at 80 meters per minute, and Sherry swims at 60 meters per minute. At the same time, Melanie and Sherry begin swimming in straight lines to a point on the north bank of the river that is equidistant from their starting positions. The two women arrive at this point simultaneously. Find D. Hold on. I mean, I think a diagram is in order here. That's probably the best way to figure this out. So our river has some width to it, like this. Call it W, but W is equal to 264. All of the units they give are consistent with each other, so I don't really need to think about units or convert everything. The speed of the river is 14 meters per second from west to east. West, east, yeah, okay. Melanie and Sherry sit on the south bank of the river, and Melanie is downstream a distance of D. So there's Melanie, there's Sherry, and that distance is D. Relative to the water, Melanie swims 80, fine, and Sherry swims 60, fine. Let's say VM is 80, VS is 60. At the same time, Melanie and Sherry begin swimming in straight lines to a point on the north bank of the river that is equidistant from their starting positions. So if it's equidistant from their starting positions, it is it has to be in the middle of them, doesn't it not? Does it not? The two women arrive at this point simultaneously. Okay, so the main idea here is if they arrive simultaneously, then that means the northern component, or the vertical component, according to the diagram I have here, of their velocities are the same. In fact, let me write it like this. So we have VM pointing in that direction, and VS in that direction. That's their swimming speed, though. Their actual speed will have an additional horizontal component equal to 14. But the vertical components are the same because they arrive there at the same time. So we'll have to work out, I guess it's just setting up the system of equations and figuring out what this what the value of D is here. I guess the angles of things might be the same. Like the angles here are going to be the same. Oops, but also important. Maybe, I'm not totally sure. Let's just try and piece this all together. Okay. Well, we can just call it theta, right? They're the same angle. So let's say I'm going to relabel this as L because I want to use WS as VS plus V, where V is the speed of the water. According to the convention I've got, the way I've written the diagram, the vector V is 14, 0, and the actual velocity that Melanie travels at is going to be her, like this. So we don't know VS Well, hold on. Just a minute. No, this is not correct, the way I've set this up. Because, you know, if the reason it's not correct is they're actually swimming more, the velocity of them swimming relative to the water is going to be more like this. Because then when you add the velocity of the water, it puts it onto this line for both of them. Okay, I think the best thing to do is just figure out, well, actually, it might not be so straightforward to figure out what the, I mean, their vertical, oh man. Well, these velocities are actually going, the actual velocities relative to the shore, not relative to the water, are going to be exactly the same, except the x component will be a negative of each other. Right? So Ws, this is going to be Vsx, Vsy plus 14. And we know the magnitude of, we know what Vsx squared plus Vsy squared is. And Wm is this, Wmy, like so. So we know Vsy is equal to Wmy, and we know that Vsx plus 14 is equal to negative Wmx plus 14 in total, like this. Right, I'll do it in a different color here, but this is Ws, and this is Wm. Okay, so now maybe it's time to start figuring out so the total distance they go, well, let's figure out this angle theta. Cosine theta is d over 2. No, wait, hold on. We have tan theta. Tan theta is 2L over D. And tan theta is also going to be related to these quantities, right? So tan theta is also that divided by Vsy. Okay. Last equation we're going to write out. Vsx squared plus Vsy squared is equal to 60. and Vmx squared plus Vmy squared is equal to 80. So how many unknowns do I have? 1, 2, 3, 4. Let's say theta is 5 and 6. How many equations do I have? 1, 2, 3, 4, 5, 6. Oh man. Well, this is equal to, let's get rid of theta. This is equal to 2L over D. So, you have to keep in mind that L is not a variable. We know what L is. So, I mean, will it help to square this equation? I have something wrong here. These should be V's, I think. Yeah. What unknowns do I have again? I have 4 values of V, 4 velocities, and distance are unknown. And equations I have 1, 2, 3, 4, 5. So in theory, this can be solved. I also know some numbers are positive and some are negative. I know that this is negative. Right? Melanie is clearly swimming to the left. So I should be able to solve for these velocities, shouldn't I? Oh man. What if I do this? Vsx squared plus Vsy squared plus Vmx squared plus Vmy squared is equal to 140. No, that doesn't work. I might have to subtract them. Vsx squared plus Vsy squared minus Vmx squared minus Vmy squared is equal to negative 20. But Vsx is equal to Vmy. No, Vsy, Vmy. So that and that are gone. So this gives Vsx squared minus Vmx squared is equal to negative 20. This is a difference of squares. Okay. I know the sum of these is negative 28. So I have Vsx minus Vmx is equal to 20 over 28. Uh, 5 over 7. So the difference between the horizontal components . 5 over 7. And I should also feel like I've kind of gotten so deep into a lot of my algebraic manipulations that maybe there might have been an easier way to set this problem up. I've lost track of like which variables I know, which I don't know, which I have in terms of others, and which equations I've used already. But maybe let's write this as VSX is equal to 5 over 7 plus VMX. Now, does this make sense? This is negative. So in magnitude, this is going to be smaller than that in magnitude. Right? Well, not quite. Not really. Hold on. Oh, man. It does have to be, though, right? Because their vertical velocities are the same. Okay, I'm just going to keep plugging things in here and see if I can get something out of it. VSX plus 14. If I do something like, so they each travel a distance of d over 2 horizontally and a vertical distance of L, and I know the time, I can just equate the time of travel. So this says that d times VSX over 2, wait, multiply these together, not divide. So if the times are equal, then d over 2 VSX is equal to L over VSY. And I also have this. So if I solve for the x in terms of the y, now gosh, this is messy. I really feel like I haven't done this. I feel like I didn't set things up in the best way. So now I'm just left with a total mess of variables and relations. how do I solve for this vertical velocity? This is a big number too, right? L is 200 and something, so L squared is quite large. I don't really want to have to square a 3-digit number to figure this out. Feel like I actually feel like I need to start again and be a little bit more organized. It's going to be really hard to get my previous approach out of my head. Let's go directly to their actual speed. Okay. So I know that ym equals ys and xs plus 14. Oh, let me just write this as xs plus xm is equal to negative 28. This is 4 equations and 4 unknowns. So let's try and solve this then. So, I mean, I've used each of these equations, but I still don't have like a solution. Is it because I This might get it. Okay, so I have xm. Finally. Let's say negative 14 minus 25 over 70 is equal to xm. But this, when I square this is already, oh, 60 squared and 80 squared. $60 squared minus 80 squared. Oh my goodness. I'm just gonna get rid of this and go through it again. Okay, this is a little bit nicer. Xs minus xm is equal to negative 100. Okay, so xs is xm minus 100. But xm is already negative, isn't it? What am I doing wrong? Oh, this is negative. This is positive. Positive. Okay. Back in action. So then, what did I do before that I deleted? Did I just xs squared plus xm squared, that's equal to 60. No. Xs plus ys. So this is xm plus 100 squared plus ys squared. Squared plus 200xm plus 100 squared plus ys is ym. Xm plus ym both squared. Oh my goodness. Oh my goodness, why am I forgetting this? 60 squared is equal to 80 squared plus 200 xm plus 100 squared. Okay. 100 times 36 is equal to 100 times 64 plus 200 xm plus 100 times 100. (36) is equal to 64 plus 2xm plus 100. 36 minus 164 is equal to 2xm. 18 minus 82 is equal to xm. Xm is equal to negative 64. Finally. Okay. So this says that xs where are we? Xs is that plus 100. 36. When I add them together, I should get is that right? Let me make sure. Xm plus xs should be negative 28. (64 minus 36). Yes. Okay. Now for one of the vertical velocities. Okay. Ys squared is equal to 60 squared minus xs squared. So ys squared is 64 times 36. So ys is 8 times 6 is 48. And finally we can compute, well, we can compute the time. So the time is the width divided by this, so that's 264 divided by 48. That's got to divide, right? Well, it's divided by 2. 132 divided by 24 divided by 2 again. 66 divided by 12 is divisible by 3. 22 over 4. 11 over 2. And that's also equal to time is equal to the horizontal distance divided by Vx plus 14. Sorry, xs plus 14. So xs plus 14 times 11 is equal to this distance d. xs is 36 36 plus 14, is that just 50? So 550 is the distance d. That's what I get. I really don't want to have to go back and check all of my work again. In particular, some arithmetic stuff like here. Yeah, I think setting this problem up in a little bit of a nicer way obviously helped get through it more quickly. 4 equations, 4 unknowns, solve it. Really silly of me to make this mistake, forgetting the square for such a long time. But of course the numbers here are chosen in such a way that solving for each of these 4 quantities isn't actually that bad. So my answer is 550. I hope that's correct. If it's not, I'll let you know. But I can't be sure that I'll find exactly where my mistake was. Thanks for watching.